Hello, this is Mr. Kovac once again, working in our Algebra 2 course here. We're going to be talking about section 4.5 today, which is solving equations by factoring. So our objective is going to factor quadratic equations and then use those factors to help solve it. All right, so in order to do that, we need to remember the zero product property. The zero product property states that if you have a times b equaling 0, this can be true if and only if a is equal to 0 or b is equal to 0. Which means if you have a product, one of the two pieces has to be 0. For instance, in the example we have here, we have x plus 3, that quantity, times x minus 4 is equal to 0. Since we are multiplying x plus 3 and x minus 4, one of these two has to be equal to 0. So we would set them both equal to 0 to find solutions. And then it's a very simple process here where we would subtract 3 and we get x equals negative 3. Or on the other hand, we could say this other one, factor, x minus 4 equals 0, add 4 and you would get your solution there, x equals 4. Okay. So that would be the answer for the equation we have listed there. Now, of course, they don't always start out factored. Let's take a look at some that don't and see if we can use our factoring tools to help us solve these problems. So I look at this first one, I've got x squared minus 5x minus 50, and that's equal to 0. And that's great that it's equal to 0, because when we're applying factoring, we want to set the equation equal to 0. Then we look, we remember our factoring rules, our factoring tree. Is there a GCF? No, there is not. So then I look, I have three terms. I'm going to try the AC method, which is also sometimes known as the product sum method. So I go ahead and make my t-chart. I've got 1 times negative 50, all right, which is negative 50, and then negative 5 is our b. What two numbers multiply to give us negative 50? And when we add them together, we get negative 5. And hopefully we're thinking negative 10 times 5, positive 5. So we take those two, we plug it into our equation. We're going to use that to help us factor. So x squared minus 10x plus 5x minus 50 equals 0. Okay, so then we have that starting point. We've created 4 terms, so we can do our grouping. GCF for the first one is x, left with x minus 10. GCF of the second group is a plus 5, so we're left with x minus 10 again. And this is equal to 0. All right, so we've got x minus 10 in both cases, so we can factor that x minus 10 out. And in the other parenthesis, we would write x plus 5. That would be our other factor there. Both of them still being equal to 0. And the party marches on. So now we've got it to the factored form. We look at it, we factored it. Can we factor it anymore? And the answer is no. So we've got a product, x minus 10 times x plus 5. So x minus 10 is 0, or x plus 5 is 0. And we solve. So our solutions for this particular quadratic equation is going to be x equals 10, or, let me try that again, x equals 10, or x equals negative 5. There we go. AC method coming to our rescue to help us solve this equation. So that's one way to go about solving it. We look over here, we've got another example, x squared equals 16. Again, we have to remember, we want to get the equation set equal to 0, so we're going to subtract 16. We end up with x squared minus 16 is equal to 0. So once again, we're trying to use factoring to help us get this problem done. I look at it. Is there a GCF? There is not. So then I look, how many terms do I have? I see I have an x squared and a 16. I have 2 terms. So the next question I want to ask myself is, am I subtracting these 2 terms from each other? I am. So I have a difference. Hopefully now that's cluing us in that we potentially have the difference of 2 squares, because we have 2 terms, we have a difference. The last question is, are they perfect squares? So I look at it, I've got x squared. That is definitely a perfect square. So x to the power of 2 minus 16, that's a perfect square as well, because that's the same as 4 squared. this is equal to 0. So hopefully we're remembering our difference of square factoring method, which very simply stated is if we have x squared minus 4 squared, we can rewrite that as x minus 4 times x plus 4. And that is equal to 0. So now we have it factored. Is there any more factoring we can do? And I don't see it. So we're going to go ahead and set each factor equal to 0. X minus 4 equals 0, or x plus 4 equals 0. There we are, which means our solutions, x equals 4, or x equals negative 4. There it is. Oh, what fun. And now we are done. So, we take a look at that. Let's try another one. Practice makes perfect. Extra examples never hurt anyone. Again, we want to get our equation equal to 0. So in order to do that, we have to subtract 6 from both sides. 6y squared plus 5y minus 6 equals 0. I look, do I have a GCF? Sadly, I do not. Therefore, I must start the next phase, and I look, and I have 3 terms, which makes me think automatically AC method. So, set up my t-chart. We're going to get negative 36 on the left, because it's positive 6 times negative 6, and positive 5 on the right. So hoping that maybe we can find a factor set here, a pair of factors of 36. So again, I am thinking 3 and 12. That's not going to get me 5 though. I'm thinking 6 and 6. That's not going to get me 5. 4 and 9. That's an interesting set. So again, we could go ahead and run through. 1 times 36, 2 times 18, 3 times 12, 4 times 9. And I can think, that somehow I could manipulate that to get to positive 5. So these other ones aren't working for me. I can automatically cross them off. And once we get to that set we know works, we can go ahead and stop. Now the question is, what multiplies to give us negative 36 adds to positive 5? One of the numbers has to be negative. The smaller one's going to be negative in this case. So 6y squared plus 5y minus 6 is going to be transformed into 6y squared minus 4y plus 9y minus 6 equals 0. So we do that so that we can go ahead and group them up, right? Grouping the first two, GCF 2y times 3y minus 2. Second one, we're looking at it, plus 3 is coming out. Look out, and we're left with 3y minus 2 equal to 0. 3y minus 2, common there, so we can factor the 3y minus 2 out, and write what's left, 2y plus 3. So we now have just completed factoring, and now we have to solve. So we go ahead and start. I have 2 things being multiplied. I don't think I can factor them anymore, so the product is equal to 0. Each piece of our product is potentially equal to 0, so we say 3y minus 2 is equal to 0, or 2y plus 3 equals 0. And then from there, I'm going to solve by adding 2. So 3y equals 2. Divide by 3. Y is going to equal 2/3. Or, solving the other side, we would subtract 3, meaning 2y would be equal to negative 3. And then we would divide by positive 2 to give us a y that is equal to negative 3 divided by 2. And there's our 2 solutions. Very wonderful, very hopeful, very happy. All right, one last example, I think, to really tie it all off, factoring and solving. I look once again at GCF. That is the first rule of factoring. And I can see by looking at this, I can take an x out of each term we have here, and that leaves us with 3x minus 4 equaling 0. All right, so now I've got a product. I cannot factor what is, I took a GCF out. I've got a product. I could stop here and try to solve, but I want to take my time. Look, can I factor what's inside the parenthesis anymore? 3x minus 4. There are two terms. We are subtracting. Is it possibly the difference of two squares? I look, 4 is a perfect square, 3x is not, so sadly we have to stop there. 3x is not a perfect square, which though is all right. We have a product. We can go ahead and solve. So we would say x is equal to 0, or 3x minus 4 is equal to 0. Now thankfully that x was by itself, so that means x equals 0 is one of our answers. So we only have one equation to solve then now. We add 4 there. So 3x minus 4 equals 0 is changed into 3x equals 4. We divide by 3, and x is going to be 4/3. So our two solutions then, the x equals 0 or x equals 4/3. Okay, this is one that we tend to overlook sometimes because it's so simple. We see x squared, we already automatically start thinking about AC method, difference of squares. Take your time. Look for the GCF first. Enjoy.